Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello, Senior 1 students. How are you? Welcome back. Alan is my name, still with you in chemistry lessons. And we are still on our Unit 13, which is about oxygen and its properties. So we are heading into lesson 2, which is about how to test oxygen and both physical and a few parts of the chemical properties. That is what we are going to look at in today's lesson, having looked at how to prepare oxygen in the first lesson. So I always like to highlight what will be making up the lesson together with the key terms. So in today's lesson, as I said, we are going to demonstrate and observe the real test for oxygen. Exactly how would you tell that this gas is oxygen? That's what we are going to do. We are going to do it as we see what are the different observations. Then we shall go through theoretically the experiment to demonstrate that oxygen supports burning. Much of you, you've always said that in your primary, so we are going to make a quick demonstration on that. So the key terms for you not to miss are rekindling a growing sprint, rekindling or relighting. We are going to do that, you're going to see. Then you must also not forget the effect of oxygen gas onto the litmus paper, which is both red and blue. Does it have any effect or there is no effect? And that is where we have the key term as neutral to litmus papers. The third key term we are going to be looking at is combustion, the burning of substance. So those are the key 3 terms for you not to miss in this lesson. Rewriting a growing sprint, neutral to litmus paper, and combustion. The first, the rewriting and neutral to litmus paper, you're going to carry them out, you're going to see them. Objectives for this lesson are, at least you should be able to recall the physical properties of oxygen, test and confirm the presence of oxygen gas, or if it is not there, you can also use that test to tell that it is not oxygen, then demonstrate how oxygen supports burning. A quick review to the student who wasn't there in the lesson 1, please, this is what we looked at. We noticed that oxygen makes up about 21% of air in the atmosphere. And we use oxygen through respiration, that is by both plants and animals, so we take in the oxygen for converting the foods we eat to produce energy. Then, as energy is being produced or the foods are being broken down, we release carbon dioxide gas. So the carbon dioxide gas is taken up by plants, which in return release oxygen. So photosynthesis increases the amount of oxygen in the atmosphere. Respiration reduces the amount of oxygen because it is taken up from the atmosphere. But in the lab, we can prepare oxygen from different reagents. One is hydrogen peroxide, which we react it with, or which we mix it with a catalyst, manganese dioxide. So that is what we looked at. We looked at the preparation of oxygen. Endeavor to check for that content and you follow it up. So now let's go to today's content, which is laboratory test for preparation of oxygen. No, laboratory test for the presence of oxygen, not preparation, sorry. So the tests we are going to carry out, remember I told you at the start, we are going to do these tests. One, we are going to see its effect on the litmus paper. And the second, we're going to see its effect on a growing sprint. So these are the procedures that we are going to follow up. The materials, we need a sprint. We need the litmus papers, a beaker, and the reagents from which oxygen can come up. Now, we are going to actually carry out these tests together. So, first, as we said, we need hydrogen peroxide. This is hydrogen peroxide that we shall use. We need water. The purpose of water is to moisten the litmus papers. We also need manganese dioxide as a catalyst. So meaning we shall mix up these two to produce our oxygen gas. Talked of litmus papers, we have red, or what we can call pink litmus paper. Then we shall also be using blue litmus paper. These, they tell us whether the acid is, whether the gas is acidic or it is basic. If it is acidic, it turns blue litmus paper to red, and if it is basic, it turns red litmus paper to blue. You looked at these color changes with the indicator when you're studying acids and bases. That is well catered for. So, what do we need? We need the glowing sprint. We're going to be using this. This is the sprint, but it becomes glowing if we add in, if we put it on fire. We shall look at it later on. Finally, we need our test tube, which is hard, and we normally cover it to prevent the gas from escaping. At the moment, we don't have a gas. We are going to mix the reagents, these two, to produce our gas. So this is hydrogen peroxide from here. I'm going to put, using a spatula, I'm going to add some hydrogen peroxide in our test tube. Right. So this is our hydrogen peroxide. Now, we are to add a catalyst, manganese dioxide. Remember, a catalyst, we need small amount of it, little amount of it, small quantities. So we've added the catalyst. Quickly cover up. So then I shake a bit to let the reaction start occurring. If you look closely, you see some of the bubbling taking place. So the reaction is occurring and the hydrogen gas is being, oxygen gas, is being produced. Oxygen gas is being produced. Now, we can wait for a moment as the gas is getting produced. But to make our experiment faster, I had mixed the same components earlier. Because the reaction is a bit slower, it requires some time. I had mixed the same components earlier, so we are going to use this gas that is being produced to carry out our tests. This was basically to show you the components I've mixed to form up this. In here, I have the gas. Now, the first aspect is, we can push this on a side. I want you to focus much more here. The first aspect is to moisten our indicator papers. This is blue indicator paper, and I also have red. So I'm moistening them by dipping them in a beaker containing water. As you can see, no change. So this is our water. The next is we are to see how the gas that has been produced from hydrogen peroxide and the manganese will affect or will have any effect on the litmus paper. Are you noticing any change? No change happening. Now we are using our wet or moistened, if I can repeat that, moistened red indicator paper. Still, no change. So meaning that the gas that has been produced, in this case, which we are anticipating to be oxygen, has no effect on the litmus papers. Now, let's bring in our growing sprint. As I said, this is a sprint, which is basically a wooden material. It becomes growing when we light it up. So I'm going to use a matchbox to light up our growing sprint. All we need is to have it lighting up. Now, this is the growing sprint. To test, we need to see what will happen. You see what is happening? The growing sprint. You see what is happening? What has happened? Let me repeat that using some of the gas in here. I'm going to repeat it. I want you to clearly observe what is happening. Even I can use this. Let me write it up. So now it's off, but when we insert it in a beaker containing oxygen, it is relit or it is rekindled. So depending, you can notice what is happening. Depending on the amount of oxygen gas that is in the container, then the growing sprint will keep burning. So now let's put this on a side. Then we write what we've really observed. Let's put that on a side and write what we have observed. So what did we see on litmus papers? There was no observable change. Take a close look on the slide here. There was no observable change, meaning that the gas had no effect on both blue and red wet litmus papers. But with the growing sprint, it was rekindled. If you missed observing clearly, this is the illustration in here. Bring your growing sprint, part of it which is burning off, put it in a container having oxygen, it will sprout, it will be rekindled. And that is the one way where you confirm the presence of oxygen. And as I can state, that is a fact. The confirmatory test for the presence of oxygen is by using a growing sprint. When you put a growing sprint into a beaker containing oxygen, then it is rekindled. If it is rekindled, that confirms the presence of oxygen. So that is it with oxygen, our dear Senior 1 students. We can now look at the physical properties. So, oxygen, as we noticed that there is a gas oxygen, but you can't see it with our naked eye. And as such, this oxygen gas is colorless and it has no smell. You will not say that I'm smelling oxygen, it has no smell. As you already know, there is oxygen in air here, but you can't smell it and say it has this smell, or you can't see it. So it is colorless and tasteless. It is slightly denser than air, and it is slightly soluble in water. Meaning, if it is dissolved in water, it can come out in form of bubbles. If you look closely, you will notice some bubbling happening. So the oxygen gas is coming out in form of bubbles. It is slightly soluble in water. It comes out of water. So those are the main physical properties. We can highlight the chemical properties of oxygen gas. And I termed it part 1 because we are going to only look at a few properties. Then in another lesson, we are going to look at other more properties. So the chemical properties, the prominent one are, it is neutral to litmus papers. I can still show you our litmus papers, they didn't change. It become blue to turn to red or red to turn to blue. Meaning this oxygen gas is neutral. It is not acidic or basic. One other property we are going to look at is oxygen is part of air that supports burning. You've already seen when you put in a growing sprint, which is almost darkening out or blackening out, then it is relit. So it is the part of air that supports burning. And that is what we are going to quickly demonstrate. As you can see on the slide, demonstrating the part of air that supports burning. So what are the materials? We need a candle. We know candle. All of us at least have an idea of a candle. Then we need a basin or in a trough. We need a matchbox and a gas jar. And the setup is seen as you can see on the slide. Take a look on the slide. So you need water in your basin or the trough. Now bring in a gas jar. So what you need to do is, as you add your water, before you put in this candle, first bring in a gas jar. This is the gas jar. Insert it in water. When you dip it in water, you will notice the height of the air column above the water within the gas jar. You can note it as A, or you can take the measurement. It can be 10 millimeter, or it can be 10 centimeter, depending on the units you're going to use. So you measure this height. It becomes the column of air before the experimentation. Now, you remove the gas jar and bring your candle, which is burning, and put it inside the experimental setup, cover it up with the gas jar. Let it burn for some time. Then take notice what will happen. So these are the observable changes after some time. You're noticing the candle after some time, it gets off or it goes off, no more lighting. Then you notice the volume of water in the gas jar has increased. If you compare A and B, we're having A reaching here, then we're having B reaching here. B is the height or the new height of air column after the candle has gone off. This, you may not necessarily need to be having a gas jar. You can even do this in a home using a bucket. You know, when you get a bucket and you cover it over a candle, the candle will get off or will burn off. It is even biblical, it is even in the Bible that when you can't light up a lantern and then cover it up with a basket, the light will no longer be coming out. So in this case, we are carrying out experimentally, and this is the setup. So as soon as the candle goes up or goes out, then you take the measurements. So we've seen the observation that after some time, the candle will stop lighting up, and the water level in the gas jar will increase. Now, if I can ask a question, why would the candle go off after some time? Why would the candle go off after some time? Simple chemistry, simple science. Of course, when you cover the candle with a bucket or a gas jar, you prevent air from coming in. Remember, air is not passing through water. So at that moment, when the air that is inside the bucket or the gas jar gets exhausted, then the candle will no longer be having any air to support it to burn. And as such, the candle will go off. So the candle goes off because the part of air that supports burning is exhausted. Why is the water level in the basin or in any container rise up? It rises up simply because as the candle stops burning, that implies that the amount of air which supports burning in the gas jar has been eliminated or removed. It leaves a vacuum. That vacuum has to be occupied by water. So the atmospheric pressure on the water surface here pushes the water into the gas jar to occupy the vacuum created by the exhausted part of air that has been used in burning. And as such, the water level rises up. So you notice we haven't actually identified what exactly is that part of air that is supporting burning. We've noticed that the candle goes up because part of air that supports burning has been exhausted. So how do we come up to know that that part of air is either nitrogen or oxygen or whichever? How do we test the presence of that part of air? And that is identifying the active part of air that supports burning. I will take you and give you a quick summary. Remember, air is made up of nitrogen, oxygen, and other noble gases. So the part that supports burning, we call it active part of air. The part that does not support burning, we call it the inactive part of air. And that is the part that remains in the gas jar when the candle goes off. Remember, it goes off because the part that supports burning has been exhausted. So we can test the presence of oxygen in this part that does not support burning. And we test that using a growing sprint. So when you use a growing sprint on the inactive part of air, the growing sprint immediately it is put off. Meaning we do not have oxygen in the inactive part of air. So the end product is we conclude that the active part of air that supports burning is oxygen and the inactive part is nitrogen and other components, because when we tested the inactive part of air after the candle has gone off, we found that the growing sprint was not rekindled. And as such, we do not have oxygen in the inactive part of air after the candle has gone off. So that confirms that oxygen is the active part of air that supports burning. And even the test showed it, that when you're having oxygen and you bring in a growing sprint, then directly it will be rekindled. But without oxygen, then there will be no rekindling. So that is it with the testing oxygen and the properties of oxygen as regards to physical and chemical. I would wish to leave you with this self-evaluation exercise to help you conceptualize what we've looked at. So this exercise is about the preparation of oxygen and why it is prepared in that way. So that is it. So a few things I need to clarify in here is if you want to carry out any test or any experimentation, please make sure you do not do it alone. Make sure you're having the guidance from your parent or from any scientists near you. Do not do any experimentation involving heating and involving chemicals without any guidance. Let me bring that to your notice. Otherwise, thank you for being part of this lesson. I'm glad to still be with you. Alan is my name. Bye.